Okay, now that we have ourselves a very simple framework in place, it's time to start creating some objects. Basically, it's time to start putting a user interface together. Now, it's going to be a very simple one. We need to kick things off with a window. Then we're going to go from there into a view, and then from there we're going to move into a label, and we'll just see where things take us from there. Now, a window is extremely important. An iPhone application typically has only one window. In fact, you should only have one window, but windows can be layered. But that's enough window talk for now. We'll save all of that stuff for a theory type lesson that we will be having a little bit later. So let's create this window. First thing I need to do is jump back over here to my app delegate implementation file. And if you recall, we had set up our application did finish launching method. So this is where we are defining it coming from our protocol that we've implemented. So I'm going to jump down here, throw in a comment, create window. So this is where we're going to be creating our window. Now, in creating the window, once again, let me just remind you guys, I'm not setting up instance variables to hold a reference to it. Not yet. I'm going to be doing that in a few minutes. As I'm coding right now, everything is just going to be put together linearly. Step 1, step 2, step 3, making it easier for those that are new to programming and new to iPhone app programming to be able to see what all is going on. So, just helps to keep a much more focused picture. So first thing is to actually create a window object. So basically an instance of a UI window. So let's go ahead and say UI window, and we need a pointer. So pointer to window, and I went with a large W there, didn't I? So window, there we go. And we need to first go ahead and allocate, and then we'll need to initialize. So let's take a look at how that works. Again, I'm going to be doing a nested message call here. So UI window, alloc. And the initialization that I'm going to be using is going to be init with frame. So initialize with frame, and take a look at what it's expecting. It's looking for me to send in a CG rect. Okay, so this is basically a special struct. It's you could just think of it as a rectangular frame that contains an origin and a size. And the origin contains an X and a Y, and the size contains a width and a height. So basically, I'm going to hand one thing in that's going to have the X and Y position, and it's going to have the width and the height of our window. And you're going to find that as you're working with UI views, as you're working with controls, which are really also views, more on that later, everything that we put together is going to be within a frame. So we're always going to be creating frames. So you really need to get comfortable with this quickly. So to create a frame, I'm not going to put it right here. I want to keep things very easy and clear to see. So let's go ahead and just close this off. And while I know this is indeed an error at the moment, let's jump up right above it and create a variable of type CGRect. So CGRect, and let's call this screen bounds. Now what I want to do for screen bounds is set up a CGRect, and fortunately for us there's a function we can use that makes it nice and simple called CGRect make. Look at that. Now that's looking for us basically to give it, as I had said, an X, a Y, a width, and a height. And they are all of type CG float. So let's just go ahead and jump over. So for our X position, let's just go with 0. Let's jump over here to our Y position and go with 0. Width, height. Now, we're going to go about this the long way / the wrong way first. It's going to help make things a little bit more clear when we start using some of the fancier calls that are recommended when creating the frame for your window. So for the width, basically, in our portrait mode, we have 320 pixels across, 480 from top to bottom. But also, we have that status bar on the iPhone at the top. So unless you go in and specify that it needs to be turned off when your application launches, that's going to be there with your app running. And that thing is 20 pixels high. That means we're going to go ahead and put in a width of 320 pixels. And I'm going to jump over here. I so do 0.0, 320.0, just letting you guys know with the float formation and everything. But I'm just keeping the numbers looking even simple and clean. Okay, now jumping over to this one. Again, 480 pixels from top to bottom. That's our height. Minus, so let's go ahead and subtract off a little bit of space. Let's knock off that 20 for the status bar that's there. So let's go ahead and say 460. Okay. Now let's go ahead and terminate this statement. So at this point, this guy is going to return back a CG rect that's going to be stored in our screen bounds. So now we can come over here and use our screen bounds. Beautiful. That is going to create a window for us. But when the window is created, it is hidden by default. And this allows you to set up your view controllers and your views and start putting all of your UI controls and getting your UI set up. And then you show your window and there is no flicker or anything. Just everything shows at once. So in this case, let's just go ahead and jump on down. And we're going to do window, make. And so we're just messaging our window object. So we're going to say make key and visible, like such. And this is going to, as a matter of fact, we can just go and put a comment up here, make the window visible, like such. So let's go ahead and save this off. Now what I'd like to do is run it. So I'm just going to do a Command R to build and run. This is going to bring up our simulator, and the application has launched. There you go. It's running. There's a window now. We've created the window, but we don't see the window. So let's do something to the window to prove that it's actually there. How about something like maybe changing its color? So to do that, let's just go ahead and jump out of our application, come back in here. So after we have created our window so that it has now been defined, let's go ahead and set a back color. So I'm going to come in here and do window dot back color. By the way, you're also going to see me jumping back and forth between Objective-C's 2.0's new dot notation, and you'll also see me using messages, object messaging a lot. So I'll be using a combination of the two. It's just whatever suits me at the moment. And sometimes I'm forced into having to use certain ones, or messaging, that is. So anyways, so we're going to set the back color of our window. So back color of the window is going to be looking for a UI color. So I'm just going to make a call to UI color. And then there are some predefined ones. If you hit escape, you can go in there, and if you just start digging around, you'll see like black color, blue color, brown color. You can also specify RGB and an alpha. We're not gonna do all of that. Again, later on we can have some theory lectures over how UI color works. But right now, let's just do something like gray color. And we can see it, right? So we'll set that up. So that is going to set our background color for the window, and then the window will be made visible. So again, let's just do a Command S to save this out, and then we'll just simply build and run. So Command R, woo, there's the window, but we have a problem. If you look very carefully, you're going to notice that it ends right here, and then we have this black space up underneath it. We should never have any black space. Apple will tell you that when you define your window should always be the size of your entire viewable area in which you can display an application. You should never have your window less than the viewable area. Look at the height right here. 20 pixels. 20 pixels. So this window is actually being set up here at 0, 0, so it's up underneath this. This status bar right here is in its own window layered on top of our window. So we need to kind of maybe shift this guy around. So we could do that simply enough. We could come in here and jump out of this. Let's come back to our code. And remember when we made our CG rectangle? Let's just come up in there and change. We've got X. We've got Y. What if we push Y down by 20 pixels? Again, we'll just do a Command save and Command build and run. So Command R. And take a look at that. What do we have now? We are all the way down to the bottom. It was like almost for a second I couldn't tell with the highlight from my lamp, but we are all the way down to the bottom, so everything's now filling out properly. That is what you want. But the way in which I am making the CG rect is not how you would want to go about it for real. The way you would want to go about it is you would want to actually talk to the screen object, and you'd want to say, hey, what's available for my screen, and let it give you back the space that's available, not for your screen, but for your application. So to do that, instead of using this method, Let's go ahead and write the new one, then we'll take out the other one just so you can see the differences. What we're going to do is, again, we're looking for a CG rect, and it's going to be screen bounds. Now, we're going to talk to the UI screen, and we're going to ask UI screen by messaging it main screen, and we're asking for it to send back to us our screen, our device screen. So by coming in here, let's go ahead and do that first. So we're going to say UI screen, and then we're going to say main screen, like such. Now the result back to that is going to be pointing to our device screen that we can use, and then we can turn around and ask it, what's the application frame that's available? And then it'll give back to me a CG rect that's already set up for what is truly available. So let's go ahead and nest this and come over here and do a application frame, like such. So we'll go ahead and set that up. Go ahead and terminate that off. So the difference between this line where we made our own CG rect and this line where we're calling on our screen to tell us what's available. So let's go ahead and delete this first line. So we'll simply jump back and get that out and save, and Command B will build. Everything built successfully. So let's go ahead and do a Command R to run. So build and run. Look at that. It looks exactly the same. So that's fantastic. But we've introduced a very interesting problem that may escape you, or if you're completely new to working with this particular format, you may not easily see it at first. But that is, now we're offset by 20 pixels, and when we bring a view in here and we set the view up, you're going to find that as we specify things, we're going to find those offset by 20 pixels down. We'll fix that shortly when I come back in and demonstrate exactly what's going on. So at this point, we've got a window in place. All right, now let's do just a little bit of cleanup, if you will. I do want to go ahead and create that instance variable that I was talking about, because we're going to go ahead and get a little bit of memory management into place. So let's go ahead and jump back out of our application. I'm going to come over here. So you guys, again, you're going to see me create things linearly here, but then you're going to see me jump back over here, and this is where I'm going to start defining my instance variables. So I want to come back over here, and we're going to be making a UI window, and we're just going to call it the same thing. Whoops. So it's going to be a pointer window. And now what I want to do is jump down up under properties, and then up under properties we're going to simply use a compiler directive property. There we go. And we're going to set a couple attributes. First of all, by default, properties are atomic, and that means that when you synthesize the accessors for a property, when the compiler does that, it looks at the attributes you've set, and if you haven't set anything dealing with atomic or non-atomic, then it puts in the code required for locking, for working with a multi-threaded application. That is not a concern of ours right now. In fact, most of the time in creating iPhone applications, you're going to come in here and put non-atomic. And the reason we're putting that is because we are simply telling the compiler, when we synthesize our accessors, the compiler is going to look at the @property directive here, and it's going to treat this as a set of instructions. And it's going to see non-atomic, and it's going to know, hey, I don't need to put all this extra code to handle locking and all that good stuff. So next thing we want to do is I'm going to put retain in here. What retain is going to do, it's going to tell the compiler that when you set the accessor up, the set accessor, it basically needs to first check the reference that you're sending in to set for a window and make sure that we're not already set to that. If we're not already set to that, so that means we're looking at somebody else. Let's release whoever we're looking at and then point ourselves at the new one and make sure that we up the retain count of the new guy. Now, I know for those of you that may be new to programming with Objective-C and you may not be familiar with the reference counting style of memory management, this is probably going to seem extremely confusing. But don't worry, I'm going to have some memory management videos coming up. Just know that right now, we don't have garbage collection on the iPhone. So we will be relying on reference counting, and reference counting simply means that when an object is instantiated, it has a retain count of 1. You can easily up the retain count yourself by simply sending a message to that object telling it to retain. The bottom line is, as other objects that are holding references to your object release it, Every release decrements the retain count by 1. When the retain count gets to 0, it automatically calls its own dealloc method. So managing memory is very important here. The iPhone does not have a lot of memory, and you really want to be cautious. You don't want to start throwing a lot of stuff into auto-release pools because that can be bad in the long run, especially if you've got loops going on with the creation of lots of objects. And you want to make sure that everything is getting properly released. You don't want memory leaks. But we will talk about using instruments a little bit later, and I will show you guys how with instruments we can basically profile and hunt for leaks. But with this, let's go ahead and finish setting this up. So we've now instructed the compiler that this will be non-atomic and it will be required to retain whatever reference is passed in. So to finish this off, it will be a UI window. And again, the name is just simply window. So there you go. We've set that up, but this is nothing more, the way I like to describe it, is nothing more than instructions for the compiler, so that if the compiler was told to synthesize, let me say that one more time, synthesize the accessor methods, which are the getters and the setters for this instanced variable, it needs to follow the instructions set forth by the attributes set here. So let's go ahead and tell the compiler, hey, we need to synthesize the accessor methods. So I'm going to simply make sure I save, so Command S. Let's jump back over to the implementation, and that's why I put my comments here, just so that you guys could see I was coming back to this. So we just simply give a compiler directive, so at synthesize, and then we can jump over and say we're going to synthesize window. That's going to automatically set our window up for us. Now the problem we have at the moment, while the setter is doing a great job of managing its memory, making sure that when it releases an object, because it's now been assigned a new object, it properly releases and properly retains, that's fantastic. But when the application comes to an end, there's nothing telling it to decrement that final retain count that it's holding. So what we're going to do is we're simply going to come down here and we are going to put in an override. We're going to set up dealloc. So again, dealloc is going to be called when a retain count hits 0. So with this, when it gets automatically called, we're simply going to come in here and we're going to say, look, our window, it needs a release command. That release command simply decrements. But if the release count, or the retain count is only 1, this release will knock it to 0 and it'll cause it to be properly deallocated. So let's go ahead and put the terminator there. And this is the only time you'll ever find yourself calling dealloc, or it should be the only time. I'm just simply going to say super dealloc. We want to make sure that we tell our super class to continue on with deallocation. So that's very important. So we'll go ahead and set that up in place. And so now with everything there, we can go ahead and make one final change, save, build, test, and that'll wrap up the video. That final change is by having this set up right here, the UI window space and a pointer for window. We're setting up a local pointer. And this is going to kind of override our instanced variable. We don't want that there, and we don't need that there. All we have to do now is simply refer to window, because window has been set up as an instanced variable belonging to our AppDelegate class. Now, with it, we've got accessors, we've got getters, we've got setters, and we have that object in scope, the reference to that object. So right here, this instance variable is going to hold a reference to the object, and here's where we actually create the object, and we just work with window like normal, and at the end of the day it's going to end up getting released. So let's go ahead and do Command Save and Command R we'll just go ahead and compile and run, or build and run. So there you go. Everything still works exactly the same. Color's been changed, but we're now setting our frame properly by asking the screen exactly what is the application frame available that I need to put my window in. And then Window's in place. It's now being stored in an instanced variable in the application delegate, which is fantastic. So that meaning we can get back to it and we can refer to it if need be. And it is being simply released from memory once our application delegate is destroyed. So with that, that is going to wrap up this video. Again, the idea was to simply create a window. And we've got that. In the next video, we're going to make things a little more interesting by creating our first view and label. So that concludes this video. Thanks a lot, guys.